Jake has published on numerous topics, including conflict, economic development, security and technology, the terrorist dilemma and small wars, big data. And his fieldwork spans many continents even. He went to Afghanistan, Colombia, India, and Pakistan. He's also a recipient of the 2016 Karl Deutsch Award from the International Studies Association. And he has advised government agencies, NGOs, tech companies on a wide range of topics. So it just goes on and on and on. And so we're so excited to have you with us, Jake. And so without further ado, I hand over to you.
Thank you so much for that kind introduction. That was really wonderful. And I'm very excited to share this work with you. What I'm hoping we can do is I'll talk for 20 to 30 minutes, lay out a perspective on what kinds of things I think we need to better govern digital spaces, and then have some discussion around this to flag where we're going. I think about digital governance as something that spans both the actions of regulators, that's how we normally think about it, but also civil society, the choices individuals make, and also the choices that policy teams at technology companies make, because right now they are the primary governance owners of these large digital commons. And so we want to think about the different kinds of resources that they need to understand the spaces and govern them in the ways that we govern other shared spaces like the economy, the environment, education, public health, etc. And the theme of the talk, just to give it away from the start, is that understanding these spaces is a financing and organizational problem. It is no longer a legal or technology problem. And I'll try and justify that in the course of the talk. So with that laid down, one other thing, which is I will do my best to watch the screen for raised hands. And please feel free to interrupt me as we go. I'm much more comfortable in that setting. Okay, so with that said, let me share my screen and we can get started here. All right. So this talk is in part based on this new piece that I did as part of a special issue on platform governance for the Annals of the American Academy of Political and Social Science. Big shout out to Tracy Mears and Sudhir Venkatesh, who organized that. When we think about major scientific instruments in society, and we talk about instruments that we need to measure different streams, we often think about things like the Perseverance Mars rover, these big physical objects that many people come together to develop and build that cost hundreds of millions or billions of dollars, and they have dozens of institutions engaging in them. But there are other ways that we instrument society that go less remarked upon, but are in many ways a better fit for thinking about digital environments. And so here are a couple of examples. The Demographic and Health Surveys is an effort that USAID started funding back in 1985 to do different kinds of surveys of maternal child health and different outcomes around family life and family success in countries around the world. There have been tens of thousands of citations to DHS work to date. DHS publications have contributed to more than 1,000 different research papers. And what DHS has done in these surveys in countries around the world is they provide both the basic demographics and geolocation for the individual respondents, which enable it to be linked to all kinds of studies. And so people have used it to understand the gender gap in health, to understand the impact of construction projects, to understand the impact of aid, to study corruption, to study the impacts of democracy on maternal health and child health and the thriving of children. So a massive number of topics, well beyond what was originally envisioned by the funders. The second example here is the US National Assessment of Educational Progress. Almost every country around the world invests hugely in measuring the educational performance of its students. In the US in FY25, we spent $190 million on maintaining the NAEP program. And so we think about these often as something different than big scientific instruments, but ultimately what we're doing is we are instrumenting parts of society. With DHS, we're instrumenting public health. With NAEP, we're instrumenting education. What we get out of these kinds of efforts is we get these this knowledge that you can't get in any other way. So I flagged the IPCC 2024 report here for a couple reasons. One is that it builds on the work of more than 10,000 scientists around the world to generate consensus around what's happening in the physical environment. But the second is that it builds critically on 50 years of international investment in Earth observation systems, scientists coming together to identify things they need to measure, and developing, in some cases, wildly expensive instruments that we put up in orbit and then build massive data processing architecture to understand that data in order to generate the knowledge here. That's possibly the largest scale example. And on the right here is an example of labor force statistics, and I'll talk more about how those are used here in just a minute. Okay, so what are the problems in the information environment that we are worried about? And these are just some recent headlines, mostly focused on technology and mental health. And what I want to flag here is that as we think about these harms, we are missing, in many ways, the basic measurement infrastructure to understand what goes on. So we have these isolated examples of chatbots running amok or people becoming addicted to social media that lead to lawsuits, but we don't actually know, on average, how are these systems working for the majority of people. It's quite hard to measure. I'll talk about we have better measures of production than we do of consumption or algorithmic values. And so as we think about these large-scale concerns, which affect in ways that, depending on your perspective, are either small or quite large, we don't actually know how big these problems are. And in different countries around the world, we're starting to significantly limit access to social media in ways that could be beneficial to health, could be harmful. They might have heterogeneous effects across different populations. And we're doing it with nothing like the evidence base that we would demand for economic interventions, education interventions, et cetera. And that is a problem that we believe research infrastructure can solve. So let's talk about just a few of the research pain points. And what I've flagged here, this is from a graphic we developed about a year and a half ago based on surveys with a few hundred people. But what I want to flag is that as you think about the research process, oftentimes the focus in the discussion around digital domains has been around data and data access. Yes, Egon, you had a question.
Hi, sorry. Just because I've heard this point being made a couple of times in the past 2 weeks ahead of the LA trial, do we not have evidence that the activation of social media has positive effects on at least mental health?
So we have a few different kinds of evidence on this, and they vary in quality. So we have very good evidence, at least from my perspective, very good causal evidence that the initial rollout of 3G and social media had negative mental health effects on people who had pre-existing vulnerabilities. We have an increasing body of evidence that short-term deactivation has positive mental health consequences, on average in a few different countries. And my colleague Nick Kuiper has just finished a phenomenal piece of research that shows that if you have whole families deactivate in Indonesia as opposed to individuals, the effects are much, much larger. And so there is an emerging body of evidence. But the point that I think is important is it is not nearly at the scale of what we look for in other policy domains. So if we think this is a global problem that's affecting the mental health of everyone who's on social media around the world, who spends significant time in digital environments around the world, that's almost everyone in the world at this point. That's a massive problem. And the measurement infrastructure investments are not nearly to the scale of the problem. And I think that's the key thing to keep in mind. That the quality and quantity of evidence is not fit for purpose. And so then we want to think about how do you improve the quality and quantity of evidence. And what this slide is intended to highlight is that there is a huge range of pain points in this process that go well beyond collecting data. And almost all of these benefit from economies of scale. So one that we might often not think about is human subjects protections rules and ethics. That kind of top row in compliance with GDPR. That's often a significant pain point for researchers. Often researchers are not following their obligations under the GDPR, or there's great debate about whether they're protecting the data in ways that different modes of ethics will require. IRBs will often ask for people to put in place very challenging and extensive data protection rules. And those are huge costs to individual researchers, and they all benefit from centralization. Standardized data stores with protections and security against data exfiltration would solve many of these concerns and take a lot of effort off individual researchers and institutions. And so there are opportunities there to make that part of the process easier. Obviously, reliance on platform APIs is an issue, long-term archival data. There's just a huge number of different points in the process that right now each individual research group has to handle on their own, which we think is quite inefficient. And so we're working on some of these at Princeton. Other groups are working on different ones of these. But as we looked at this research process, the thing that just jumped out is that we're not, as a community, thinking about how do we make this easier for everyone. And we're not building these scientific collaborations that you have had in other fields to make those processes easier. And so as we get more into the conversation, it's worth thinking about what are the different pain points that aren't just the data that the DSA is oriented around, or the GDP Article 20 data takeouts might enable you to handle. There are other phases in the process that research infrastructure can support, and we often don't think about those. Okay, so this is the problem. I won't belabor it since I want to make sure we have plenty of time for questions. But again, it's not that we can't do the research. It's not that we don't have individually excellent pieces of research that leverage large volumes of data, amazing quantitative and ethnographic work to understand benefits and harms in the information environment. It's that the scale of the evidence is not at the scale of the problems that we're worried about. That's the concern. So in other places, those kinds of national accounts serve a number of key functions, and I want to talk about these for a minute. The first is that they can help flag problems and create pressure for action. And in this space, the Earth observation data is probably the most important to think about. Over time, as evidence accumulated of anthropomorphic climate change, you started to get questions about the scientific consensus. More evidence built up, the scientific consensus became stronger, and that eventually drove significant efforts towards global regulatory action and huge action in many different states. And so what those data did was they flagged problems. They enabled people to generate the evidence base that demonstrated something was a problem. The second thing they do, which is quite important, is the national accounts, whether in the economy is probably the most important of these, and I'll give a more specific example of that in a few minutes. They create a framework for policy assessment, and that enables learning. So if you have a baseline measured over time, you can start to look at changes over time. You can start to look at differential effects on different populations. It gives you a way, if you are a policymaker, to answer the question, often imperfectly, of whether or not a given policy is working. And in the information environment for the policy teams at companies and for regulators, we don't have those kinds of long-run longitudinal measurements in the same way. And that creates barriers to learning and policy improvement that we don't have in other spaces. And then the last thing national accounts do is they highlight the trends which enable projections and policy planning. Again, we don't have a good sense, for example, of how much people are turning to AI-driven tools for information acquisition and production. There's lots of conversation about AI slop taking over the internet and what might be happening with changes in the information environment, but reliable evidence on that is scarce. And so if we are thinking about how long do we have to put in place some of the new institutions we might need to deal with changes in information acquisition and to think about different regulatory policy, we don't really have the underlying information to do that policy planning. So what are some success stories? So I want to talk about the value of labor force surveys here for a minute. So in the United States, in the EU, and many countries around the world, we have implemented what are called automatic stabilizers. And this goes back to this 1955 paper in Journal of Political Economy that I've underlined there by Kerry Brown, The Static Theory of Automatic Fiscal Stabilization. And what Brown did is he took the labor force surveys that existed for the US and basically made a theoretical and empirical case for having an institution that in a given state, when the unemployment rate crosses a certain threshold, automatically unemployment benefits become more generous. And what that does is when the economy starts to take a dip, it injects money into the economy without any need for regulatory action or for legal action. That then begins to increase the demand. People have more money. You've buffered people against the shock, and you reduce the duration of the negative effect. And that work, that body of evidence, was a key part in the 1970 under Nixon of passing in the US the first temporary extension of state unemployment benefits in states that exceeded a certain level of unemployment. That has been extended and continued in US policy since then. And so I've just excerpted the most recent enactment of the act that puts those in place. And you can see they introduced this idea of state level on-off indicators for unemployment benefits. So huge change in benefits that has been shown to be very economically beneficial and beneficial for people's longevity and the education of their children, stability of marriage. A whole range of studies have been done on this, comes out of a study that was enabled by the existence of labor force surveys. And just to benchmark what gets spent on these in the US, in the last few years, labor force surveys in the US have cost approximately 650 to 750 million in a given year for the Bureau of Labor Statistics to collect its three main surveys: wages and working conditions, unemployment, and prices. And they've had a staff of between 1,600 and 1,800 people working on those surveys. So this is a massive effort to measure the economy that leads to some of these policy changes. Second example I want to give is one from my own work that is an example of creating a way to think about policy effectiveness. And here we're not relying on, well, we're using a mix of government statistics and others. So what I'm showing you is the trends in the number of claims per 100 individuals for depression, anxiety, and eating disorders on the left, and on the right for fractures, eczema, and skin infections. In that brown line, publicly insured, that's every insurance claim of someone on Medicaid in the US. So that's between about 40 and 60 million people in any given year over the time period. And then in green there on the bottom is private insurer data that covers between 20 and about 40% of the privately insured individuals in the US. So collectively tens of millions of individuals. And this is new work with colleagues at PSE. What's important to highlight here is a couple things. One, we don't see a change in the rate of mental health claims when Twitter and Instagram switched to an algorithmic feed in 2016, which is perhaps, you could take perhaps as evidence against the thesis that the negative mental health consequences attributed to social media are coming from the algorithm specifically, as opposed to other things they might do. But more importantly, we can do this kind of analysis because this massive scale data was put in one place and we were able to access it for research purposes. And when you look at a source of plausibly exogenous variation in Twitter usage at the level of a city in the United States, what you see is there's this substantial negative effect on mental health. 1 percentage point increase in Twitter usage in a given MSA in a given year from 2010 to 2020 predicts about 3 additional mental health related claims. To put the effect size in context, going from the median to 75th percentile of Twitter penetration is about 25% of the difference between men and women in the rate of mental health claims per 100. You don't see that for placebo claims. And importantly, if you look at the effects dynamically, you see them kick in around 2011, 2012, but no change with the introduction of the algorithmic feed in 2016 in the magnitude of this effect. So we're not talking about this paper today, but what I want to highlight is we can do this kind of analysis because the Medicaid data went to something called the Center for Medicaid Studies that then has a process of anonymizing it that then shared it with our colleagues at Rutgers. And a commercial firm, MarketScan, went around to different insurance providers all around the country and for commercial purposes pooled their claims data, which we were then able to access through the partnership with Rutgers School of Public Health. And so that large-scale data collection enables sense-making on the mental health impact of social media in a way we could not have done without those investments. Okay. So what kinds of measurements should we have? And I think there are roughly 4 that have come up in lots of conversations about this. And I'm going to give you some examples of each. The first is production. What are people posting? What are they saying online? This is most of the collections we have. This is what was available historically through CrowdTangle from Facebook. This is what was available through the Twitter API. When people crawl and pull down Blue Sky, that is what they are getting. It's what people produce and put out. Second thing we might want to measure is consumption. How are people actually interacting with the information environment? That is a different challenge. It lets you observe different things, and we'll talk about that in a minute. The third thing we might want to understand is what are the values behind the algorithms that are sorting and organizing content for people? And then the fourth is a new one that's come up, which is how are AI models responding on different topics. And so I'm going to give you examples of what is being done right now on 3 of 4 of those. And then we'll kind of talk about why I think 3 is missing. Okay, so what's happening on production? Historically, this has been covered fairly imperfectly by commercial social listening tools. I have Brandwatch and Social Blade on here just because randomly chose those. And what these organizations do is they sell to brands and marketers and advertisers different kinds of measures of what is happening on social media, often imperfect, often with limited information on their method. Often they don't measure quite the things that we would want as social scientists. And typically they're doing so cooperatively with different companies, and the deals that they strike with them for access to the data limit their ability to share raw data in significant ways. They remain extremely useful for many purposes. For example, colleagues at Cardiff University have used Brandwatch to great effect to understand the impact of different Russian information operations in Eastern Europe and other areas around the world. There's now an emerging group of organizations that are doing a very good job of this for research purposes. So Algorithmic Transparency Institute, a nonprofit in the US, has a wonderful tool that lets you put different accounts on different social media platforms, both fringe ones and mainstream ones, into a nice user interface, and then it shows you what they're doing over time. Very, very helpful for people who want to understand how are different politicians talking about things, how are different influencers talking about things, what's the conversation of targeted individuals. Open Measures is a company that's built a very good database, as best we can tell, of activity on a number of fringe social media platforms. And Xort is a newer company based in the EU that's doing large-scale collection of text on a number of different platforms, and their scale is quite impressive. Billions of posts, I think, per month at this point. Each of these are expensive, but not that expensive. So you can access these capabilities depending on your use case and what you can negotiate with the companies for between $20,000 and $60,000 a year. And so that seems like a lot in some contexts, except in the context of other kinds of research, that is actually a very small data collection cost. And I'll give you an example of that in a minute. Consumption. What would we want to have on consumption? Well, there are a few things we can think about here. One is we can think about the kinds of services that commercial companies provide. So on the left there, I highlighted 2, Nielsen and Comscore. What these companies do is they go out and they pay people to participate in panels and share their activity online. So Nielsen does basically all the media people consume. And this has been used in, for example, a wonderful 2020 science paper by Jennifer Allen and colleagues, where they measure the actual share of people's media consumption that is news, how much of that is on social, and show that actually it's like a vanishingly small portion of people's total media consumption. Comscore is one my team has been working with a lot. They go out and recruit a panel of people, and they work in a number of different countries around the world, who install software on either their desktop or their mobile device that lets Comscore collect their web browsing and their application usage. So with colleagues, for example, we've recently used this to study the addictiveness of short-form video, leveraging the short period in time when TikTok had short-form video, but Instagram did not, and they had the same affordances in other ways. And you can see big differences in how the populations that were similar in their application usage before they turned on one of those change over time. That's another commercial resource. Again, many different countries, depending on the country and how many years you want, 20 to 40K per year per country. But we're talking about samples of 10 to 30,000 people a month in the data with demographics and geolocation. So you can actually understand quite a lot about consumption behavior from this commercial data source. And they have very transparent methodology because that's what their customers in the advertising and marketing world demand. So that's one set of resources. And the other set of resources is academic efforts that measure consumption. So National Internet Observatory out of Northeastern has built a representative panel of American internet users and records almost everything they do online. And they're starting to make a number of those data sets public. NIO is an example of where the ethical and IRB and data management challenges are quite tricky, because as you can imagine, people's browsing behavior, their activity online is quite a sensitive thing. So you have to be very careful with how you provide that to people. So it's expensive. The budget is low millions of dollars per year for that collection. So that is a significant expense, but again, in the context of other research activities and the scale of the harm's not that significant. My team has taken a slightly different approach with Princeton Smart. That's a software tool that is open access. We're maintaining it. Other people can take it and build upon it. And what it does is allows you in a way that is fully consented by the user for people on Android devices to record regular screenshots of what is on their screen, does a bunch of OCR and data processing on it to make it easier for you to work with those data, and then sends it to an AW instance securely from the device to an AWS instance of your source. And there's a bunch of engineering behind it to make sure it's, respectful of people's devices, doesn't drain their batteries, et cetera. But in principle, one could recruit a sample of the population you're interested in, work with them to load up this tool, and then observe everything that is happening on their device. And that lets you do things you can't do with these other sources, like see what kinds of advertisements different populations are served and at what times. And then what does that do to their subsequent online engagement or their sleep behavior as observed through them being on the device or not. So there's a tremendous amount that you can do once you have that capacity. And there, the cost for larger scale measurement is not the software or the tooling, it's recruiting and maintaining the sample. And that's expensive, but is a thing a dozen research institutions around the world could do for a group of academics that were able to pool the resources to maintain those collections. So that's consumption, and my argument would be it's a more or less solved problem, but expensive to do well. Okay. And this is just a wonderful example of what you can do with another source for consumption. So this is work by a number of your colleagues in Germany. And what they did, this is one of several papers that this group has done, is they take advantage of the fact that GDPR Article 20 requires companies to allow users to download their own data. And so what they did is they recruited a sample that downloaded their data on TikTok, and they gave them some tooling to make it a little bit easier. And then they used that set of people who had responded to surveys and given data donations to analyze what they were doing on time on TikTok. Every major online platform has a GDPR Article 20 portal with which people can download data. The infrastructure that's needed to make this easy is software to speed the process for people, because different platforms have different user affordances, and software to make it easy to analyze the data, because what comes down for some platforms is quite voluminous. But in principle, again, if you have a platform you're interested in and a population you're interested in, observing what people consume is quite doable. Different platforms provide different levels of information in their data takeouts. And as Abhishek and Krishna and colleagues have shown in some other work, compliance with the laws is a little bit sketchy, but the capability is there. Okay, how much should this cost? I do some work in development economics as well. This is just the main figure from one of those papers that's forthcoming with Journal of Political Economy. What we did for this paper, though, is we went out and we did an initial canvass of every household in every village in roughly 1,000 villages in central Punjab. We then went out and did a series of surveys over 5 years with the villages, with the women in the villages, to measure and understand the barriers to accessing vocational training. And what we found in this paper, which has big implications for how you deliver development services in this area, is that simply crossing a village boundary, which is not a real physical boundary, it's a socially constructed one, leads to massive drops in enrollment for the program. And because of the way we did this, we were able to actually measure the monetary cost of that, and compensating women to leave their village required paying them an amount that was unrealistic given program budgets. And the implication of that for development practice is you have to push training out as best as you can, as far as you can into the hinterland. And we could show that the women who made it through travel benefited. The women who it became easy for, because training centers were put in their village, benefited as much as the women who had to travel. So lots of implications from this. For this project, over those many years, we raised several million pounds to do the data collection, the analysis, and work with the implementation partners to randomize their delivery of this service in the ways that are needed. This is just one of dozens of research experiments that are being done every year around the world in similar scale in countries all over the world. So the development economics profession has figured out how to mobilize levels of capital that would easily support taking some of the tools I just showed you and deploying them on representative samples in a number of European countries, in the developing world, and other places. So other fields have kind of figured out how to mobilize the scale of resources here. And so I use my own research just to highlight that, but as a way of maybe motivating people to think a little bit more about how could this field generate the resources that are needed to do larger scale data collection. Okay, algorithm values.
Jake, it would be great if you could wrap up in a couple of minutes so that we have time for questions.
Yes, absolutely. So algorithm values, I don't know what to do here. There's really no way to get these other than working with companies. But AI model outputs, I just want to show you a very nice example. So there's a lot of concern. This is from some work my colleagues and I have done recently. There's a lot of concern that AI models are going to recapitulate Russian propaganda in response to different informational queries. This is a thing that is actually quite inexpensive to measure. So with about a month of effort, we set up a pipeline that takes information from EU versus Disinfo, which is a European Union program to counter Russian propaganda. And they have a sample of about 36,000 stories the Russians have put together. From those stories, you can generate questions like this one here, turn that into prompts for an LLM, ask the LLM to respond on it. And what you can do then is you can analyze these questions at scale to understand if the concerns generated in these isolated examples are in fact widespread. And if they are, we should be really worried about what the policy teams at the AI companies are doing, because their failure to control this potential harm might have big impacts on the political information people are getting. So what did we find? Well, Russian propaganda is almost never cited in response to questions about themes that Russian propaganda puts out. And this is early work, so have to scale it up, so take that with a grain of salt. But the right column here shows you that the counter propaganda from the EU is cited, depending on the model, 3 to 12 times as often. But the more interesting thing is that in response to these questions, again, about narratives that the Kremlin itself is pushing, different models between 6 and 20% of the time approximately share the Russian perspective. But almost always, at least in Claude and Grok, when they do, they actually refute the Russian perspective, which in some ways is a way to think about that. But the differences are huge between models. So this very inexpensive audit effort, which is a thing that people could scale in principle to many more issues, shows you a couple of things. It shows you the power of the company policy teams, because there's huge differences between companies, but also that, with the exception of DeepSeek, which almost never shares the Russian perspective, they are often refuting it. So a problem that you see in isolated examples is only there a little bit in practice. So the goal of the whole talk is to convince you of that first line. This is a financial and organizational problem, not a legal or technical one. And so what would I advocate for? Panel data on consumption first. This is a thing that is readily doable with screen recordings, GDPR 20 takeouts. It is really the cost of recruiting the samples and then storing and protecting the data. That leads to the second funding priority, which is shared secure data science environments. All those frictions that I highlighted earlier, those are there. And one of the things we did 2 years ago is we looked at the productivity of different labs at producing research on the information environment. And the 4 or 5 labs that have engineering teams and dedicated compute are radical outproducers of research in top journals, because there are economies of scale to all that data science work. Production samples, which is where a lot of the focus has been, I actually think should be a slightly lower priority. as the resources are coming online to do that quite well. I showed you a number of commercial ones. There's actually a one that will likely be free that will be coming online later this year. So that is a problem that in some ways is on its way to being solved, and so is not somewhere I think we want to think about significant effort.